Okay, so the takeaway, I'll just start with the takeaway. Contamination is a real risk for all of our lunar science, a lot of our lunar science that depends on samples. The good news is that through contamination control and contamination knowledge, we can reduce this risk to our science. So what is contamination? Well, contamination can be in the form of atomic level contamination through molecular deposition. It can be through vapors, it can be through solids, it can be organic, and it can be inorganic. And this kind of just gives an idea of the reality is that constantly there are going to be materials falling close to around, our samples, and we don't have a magic bubble that prevents this. So contamination control is really about trying to reduce the contamination that could impact the samples. Contamination knowledge is kind of the tracing what contamination did happen, because we can only get it to a certain minimal level. We really only care about contamination up to the point that it impacts our science. We don't care about one single atom of any particular element. We care about enough of that material that impacts the science analysis that we want to conduct. So contamination control is kind of the active stage throughout the mission life cycle, from planning what hardware to use through the activities that are conducted through the curation back on Earth. One step in this is to kind of provide documentation and guidance to the community. So a couple of months ago, we produced the first version of our contamination control plan. And this is intended to be a kind of living document that we update as our ideas of the mission progress and as the Artemis program develops further. One part of this is things like materials that can be used. So using certain types of stainless steel or aluminum rather than something like tin or a different material that really would impact somebody's science. So these are the best materials that we can use to make everybody happy. We can prescribe certain cleaning processes to try and get the particles down, the organic residues down, things like that. And again, this depends on the science that we're going to be wanting to conduct. It's often said that we can't conduct every type of science on every type of sample, and this is true. So we need to be able to protect some samples from organics, where we might want to protect others from particular volatile species. We could talk a little bit about the mission operations, and how these are handled. Barbara mostly covered that in the previous talk. And then the last stage really is the curation. And we have a long history with Apollo. We know how these samples are affected in labs. We have tests and analyses that have been done on the real Apollo samples. And then we've also got other missions. So for example, OSIRIS-REx, Stardust, and other missions that we know how to reduce contamination through really actively choosing what we do, how we do it, what materials we use. The second part of it is contamination knowledge. And that's really, if we get a minimal amount of contamination on it, we want to be able to extract that from our data. We want to be able to tell what was contamination and what is something real lunar science. So here's an example of a background correction that Jamie did on her lab backgrounds, the blanks. And we really want to be able to extend that into the mission life cycle. If there's outgassing of an astronaut suit, we want to be able to say, okay, we think that the certain ppm of hydrogen or something came from that source. So we can take that out and really get to the true lunar science that we're trying to understand. The other part of contamination knowledge is really the active phases, the witness plates that we will put out during the build of instruments and during flight. It's taking subsamples of materials used in hardware development, so that if we do find that there's an increase in iron or molybdenum or something like that, we can go back and look, well, did the hammer impact that? Did the bag that was used to store it introduce some sort of level of contamination? So we can always have those materials there to look at. For other things like acids and things that are used in the production of the materials flown, we might not want to be able to hold some sulfuric acid for 30 years to look back on. But if we know what that material was, we can say, okay, there's where maybe some of our sulfur came from, that sort of thing. Final part of contamination knowledge are things that aren't done specifically for contamination knowledge. So here's an example from Apollo in real time. This is whenever they collected the orange glass beads. And you can imagine that on Artemis, we're going to have times when we find the unexpected. We need to know that somebody didn't kick over a bucket of orange paint whenever they got the orange glass beads. And the same if we want to find samples that have a certain amount of volatile components in them, we need to say, was that because the astronaut's suit was venting for too long for that sample compared to that sample, or any other source of contamination. The final slide really is just to engage with the community. So Artemis isn't Apollo. Apollo did a really good job with contamination control. A lot of other missions have done exceptionally well, but Artemis isn't going to be the same as any other mission. Each Artemis mission is not going to be the same as the last. So we need to find different approaches, and we'll be conducting different science and different contamination control. It can impact every type of science in a different way. And you're all the experts in this. You know your science better than anybody else. So if there are potential contaminants, if there are problems that you've had with previous mission samples, you're not sure, is that a real signal I'm seeing, or is that a background signal from terrestrial contamination? Those are things, feel free to get in contact. I don't know everything about organic geochemistry. I don't know everything about isotope geochemistry. You know it better than anybody. So protect your own science, get in contact with me, engage with the team, really to preserve the science value for the future.